Today we will start up with the explanation of the chapter Dual Nature. As few things related to this chapter you people already did in +1 standard in your chemistry. So it will be easy for you to understand this chapter. First definition in this we will cover is work function. We all know that in the metal, electrons in the outermost shell is loosely bound. They move freely about throughout the lattice of the positive ion, such as loosely bound electrons are called free electrons. That we all know that the electron in the outermost shell are loosely bound. If we will give small amount of energy to these electrons, it will be easy for those electrons to leave the surface and move out freely. The minimum amount of energy required by an electron to just escape from the metal surface is called a work function. This minimum amount of energy which is required by electron to make it free out of that bound surface, this minimum amount of energy is called work function. It depends upon two factors. One is nature of the metal, second is condition of its surface. Then in the next page, electron emission and few other methods by which we can eject the electron out of that bound surface. These few methods are given: thermoionic emission, photoelectric emission, field emission and secondary emission. You just read out these methods. They are very simple. It will be easy for you to understand these methods. Next, you people move to page number 2. At the back of the page number 2, we will start with our first topic which needs detailed explanation, and that topic is called photoelectric effect. As in the previous unit, that is wave optics, which we people have not discussed yet. So when the classes will be open, we'll explain you that unit at that time only. In that unit, we explained few terms: polarization, interference and diffraction. These three phenomena can be explained with the wave nature of the light. But according to a quantum theory, light can exist in the form of the particle nature also. For that explanation, they have given one experiment which is called photoelectric effect. So this effect will help us to understand the particle nature of the light. First of all, what is photoelectric effect? Phenomena of the ejection of electron from the metal surface when the light of some frequency falls on it is called photoelectric effect. To understand this effect, they have set up this type of apparatus. This apparatus is used to study the photoelectric effect. It is also related to the Hertz observations. What they taken over there is, they have taken here a closed chamber in which two plates are there. This is C and this is A. This is called emitter plate. A is called collector plate. They have fixed it with some amount of the potential divider so that they can apply potential positive and negative with respect to this side of the collector plate. They fixed it with the voltmeter and ammeter to just measure the amount of the current, and V means whatever potential we are applying, that we can measure with this type of the voltmeter. This emitter plate is called photosensitive plate. Here they have kept one window so that when a light of certain frequency will fall on this type of the emitter plate, then we can easily see that this window is just acting like opening. It is just acting like an opening which will allow the light to come and fall on this collector plate. So what is there in photoelectric effect? When a light of certain frequency will fall at this collector plate, and that light can come through this window W, as is the source of light. When light of certain frequency will come and fall at this emitter plate, then what will happen? Loosely bound electrons will gain the energy from that photon and get ejected out of this emitter plate. When this anode is maintained at a positive potential with respect to this emitter plate, what will happen? These electrons will started moving toward this anode because it started attracting them toward itself. So this is the phenomenon, that when light of certain frequency will fall at the emitter plate, electron will gain energy from this and make themselves free from this collector plate and started attracted towards this, make themselves free from this emitter plate and started themselves attracted toward the anode, that is a collector plate. Now in this experiment, they said we will fix few things, just like in the beginning we will fix potential and see that what is the effect of the intensity of the light source S on the amount of the current flowing through this setup. Because when light of certain frequency and certain intensity will fall on this emitter plate, then electrons will be emitted out of this and they started moving toward this second electrode, which is acting as a collector plate. Then current starts flowing because our circuit is now complete. Just to see the things, they said that in first observation we just want to see the effect of intensity of light on the photoelectric current. For that, what we have to fix here, what we will do, maintain A at positive potential. A means it's a collector plate. We will maintain collector plate at a positive potential with respect to our emitter plate C, so that the electron emitted from the emitter are accelerated toward the collector plate A. If we allow the radiation of fixed frequency, so in the beginning we have fixed frequency so that we can change the intensity of light. So in the beginning we allow the light of fixed frequency to fall on the plate C. And accelerating potential difference between two electrodes is to be kept fixed. So what we are doing, we are fixing the frequency of the light falling on the emitter plate, and secondly we are fixing the potential difference which we are applying between this collector and emitter plate. Then when this type of light of fixed frequency and potential difference will fall at this emitter plate, electrons will start moving towards the plate A, which is collector plate. Then what will happen? Photoelectric current will found to increase linearly with the intensity of the incident ray. As we keep on increasing the intensity of the incident ray, we observe that photoelectric current also increases. Hence we obtain this type of straight line graph between intensity and photoelectric current. It means when we are increasing the intensity, then we are increasing number of photoelectrons emitted, which are proportional to photoelectric current. It means if we are increasing the intensity, it means number of electrons which are emitted from the emitter plate are increased, because of which the photoelectric current will increase. This is our first observation. Then come to the second observation. For this observation, it is very important. You need to understand it very carefully. If we keep intensity I and frequency of the incident ray fixed. Now we have fixed the intensity and frequency and increase the positive potential on the plate A gradually. What will happen? We found that the photoelectric current, now we have fixed intensity and frequency both. Now we are increasing only the potential. Now we will see that with increase in potential, what will be the effect on the photoelectric current? We found that photoelectric current increase with increase in accelerating potential till a stage is reached when photoelectric current is maximum and does not increase further with increase in accelerating potential. So as we keep on increasing this positive potential, current increase and finally it will attain a constant value. This constant value of the current, which is the maximum value also, that is called as saturation current. Next, we are increasing the positive potential. Now we have to increase the negative potential also and see what will be the effect on the current. For that, now apply a negative potential on the plate A with respect to C. Now we are making our collector plate negative. What will happen then? Electrons are repelled by it. They will not be attracted by it. It means current start automatically decreasing, because now our circuit is not complete. Sufficient amount of electrons are not reaching to our collector plate. So it will gradually started decreasing. So the electrons which have sufficient kinetic energy reach the collector despite of the negative polarity, because that negative polarity is continuously repelling the electrons. So only those electrons which have sufficient kinetic energy will be able to reach this negative plate. The potential difference between two electrodes now act as a retarding potential. Why retarding potential? because it is retarding or it is stopping the motion of the electron. So that's why it is called as a retarding potential. As collector is made more and more negative, when we are increasing our collector plate with the negative potential, what will happen? Less and less number of electrons are reaching to the collector plate and our photoelectric current will begin to decrease. So it means, what is the work of our retarding potential? What our retarding potential is doing? Our retarding potential is trying to stop the current. It is trying to making the motion of electrons stop automatically. So the retarding potential is equal to the V naught, which is called stopping potential. Stopping potential is just another name for the retarding potential. No electron will reach the collector and current will be zero. So they said, when you increase this negative potential, what will happen? Current starts decreasing, right? And a particular voltage where current will be zero, that voltage is called as stopping potential. And this whole negative voltage is called as retarding potential. And this specific voltage when the photoelectric current is zero is called as stopping potential. Now what is the work of the stopping potential or retarding potential? Its work is just to decrease or making the current zero. It means maximum is the energy with the electron. Maximum is the kinetic energy of the electron. More is the amount of work done by stopping potential to make it stop. Hence, work done by stopping potential is equal to maximum kinetic energy. More is the energy content in the electron. More that electron will try to reach the collector plate. More the stopping potential has to do the work to make it stop so that they can make the current to be zero. So that's why they both are equal. So work done by stopping potential is EV naught, which will be equal to half mv maximum square. From here you can say that the stopping potential is proportional to maximum kinetic energy. So from the graph here it is clear that at V naught, which is called a stopping potential, our current will become zero. These two peaks will join here. What does this indicate? It will tell us that whatever is the intensity of light, either more or less. Whatever is the intensity of light, either more or less, the stopping potential does not depend upon the intensity. For both the intensities, you can see that the stopping potential is same. It means stopping potential does not depend upon the intensity. We find that if frequency is the same but intensity increase, the saturation current increase while stopping potential remains same. Because with the increase in intensity, I2 is greater than I1. If I2 is greater than I1, current is more because this curve is slightly above as compared to this curve. So with the increase in intensity, as we did earlier in our first conclusion, with increase in intensity, current will increase. Saturation current is also more for more intensity, but stopping potential is same for both the intensities. It means stopping potential is independent of intensity. So from here you can conclude that maximum kinetic energy is also independent of intensity. Next is effect of frequency on the stopping potential. For studying this, we have to adjust further more parameter. Intensity of the incident ray is adjusted in such a way that the saturation current is same when plate A is positive potential. Potential on the A is gradually reduced to zero and increased in the negative direction till the stopping potential is reached. The experiment is repeated for different frequency values of the stopping potential. Increase with the frequency of the incident ray. More is the frequency, greater is the maximum kinetic energy, and greater is the retarding potential required to stop the electron. That we already know from here also. If we will increase the frequency, what we are doing? We are not increasing the number of electrons ejected from the emitter plate. We are but increasing the energy content of those electrons. So with the increase in frequency, energy content is increased, because of which stopping potential is increased. So we'll move to the next page. So this is the graph which explains this behavior, that with the increase in frequency for the different frequencies, stopping potential, saturation current is same. It means current is independent of our frequency. Current only depends upon intensity, not on the frequency. But if frequencies are different, then stopping potentials will also be different. More is the frequency, more is the energy content in the electron, more is difficult to make them stop, so more is the amount of work done by stopping potential. So from this graph, this thing is also clear. Then they said, from this graph, what is the conclusion? They said if you draw a graph of stopping potential or the maximum kinetic energy with frequency, that we all know with the increase in frequency, maximum kinetic energy will increase, because of which stopping potential will also increase. So straight line graphs will be obtained. Why these graphs are not starting from here 0, but they are starting from here? This indicates that below this frequency, here in this region, below this frequency nu naught, no photoelectric effect is possible. It means the light which is falling on that emitter plate, that light must have some energy h nu. Let this be the energy of the incident photon, h nu. This is the energy of incident photon which is incidenting on this emitter plate and making the electrons go out of this emitter plate toward this collector plate. So they said that this photon should have minimum amount of energy in it, which is equal to the work function of this metal. So nu naught is called as threshold frequency. This is that minimum amount of frequency which is required for making the photoelectric effect possible. If your incident photon is having frequency less than nu naught, if your nu, that is incident photon, its frequency is less than your this nu naught, which is threshold frequency, then no photoelectric effect is possible. It only starts when the frequency minimum is equal to nu naught. After that, if the frequency is more than nu naught, the photoelectric effect will take place, and the effect of the frequency and maximum kinetic energy will be like this straight line, inclined. So from here, what we obtain from these observations, we have obtained the laws of photoelectric emission. According to first conclusion, what we have read, that photoelectric current is directly proportional to the intensity of the light, because intensity is increasing, number of electrons ejected from the emitter plate. Second observation, for the given metal, there exists a certain minimum cutoff frequency below which no photoelectric effect is possible. This is called threshold frequency. Above this threshold frequency, stopping potential and maximum kinetic energy is directly proportional to the frequency, as I explained you earlier. Photoelectric emission is instantaneous process. This is the last law of photoelectric emission, that it's an instantaneous process. Instantaneous means the time lag between the incidence of the light and the emission of the photoelectron is small, less than 10⁻⁹ second. Actually, photoelectric process is a one-to-one process. One-to-one means when one photon will fall on the metal, one electron will be ejected immediately. That's why the time lag is very, very small. So here we are driving the Einstein photoelectric equation. So this will explain our metal surface, right? This is the incident photon which will fall on the metal surface and electron will be ejected, right? So according to this, we can write that if energy of the incident photon is equal to, energy of the incident photon can be used for the two purposes. First purpose is, if energy of incident photon is h nu, some part of this energy is used for making the electron out of the metal surface, and rest energy is used to give it kinetic energy. So whatever energy will be falling on the metal surface, some of the energy will be used to overcome the work function, and leftover energy is used for the kinetic energy of the electron so that it can start moving out. So from this expression, kinetic energy can come out to be h nu minus w naught, which is called work function. Now they said this can also happen that this following photon is having energy equal to this much only, which is the work function of this emitter plate, or you can say metal. If the photon is having that much of energy only, then what will happen? Then the energy of the incident photon is only used to overcome the work function. Kinetic energy will be 0. It means in that case, according to this relation, kinetic energy is 0. Whatever is the energy h nu, now h nu will become h nu naught, because now our incident photon is having energy h nu naught. Now, so kinetic energy will be 0 in that case, and whatever energy is there with the photon, that will be used to overcome the work function. So h nu naught is equal to work function w naught. In that situation, you can substitute this value here and you can get this formula, right? And that's all for this chapter. Rest of the things will help you increasing more knowledge related to this chapter. Please read out the next pages, and if there is any doubt, you can ask me in this group only. Thank you so much.